Welcome to Spark Academy once again. We already discussed so many topics in our channel YouTube. Let's once again we see today the topic is chemical bonding. So here in Spark Academy admissions open, classroom, online coaching, short term, crash course, regular courses available. So daily live classes, in session dot clarifications, free material in our app, tips and tricks and previous year questions all available in our Spark Academy. So it is our timetable. Now it's my coupon. See. Now today see the we are going to see the chemical bonding. Yes, chemical bonding. It has weightage. For Eamcet, one question is compulsory. So what are the subtopics? We are expecting questions from chemical bonding. So in that first one is the Poisson's rule. First one, Poisson's rule. Next come to the ionic and covalent compounds related. Ionic covalent compounds. Next, hybridization. So hybridization, finding the hybridization of the central molecule. Next, VSEPR theory. So in VSEPR theory, okay, in that related to the geometry, okay, number of lone pairs, bond pairs question. Next we see which one, yes, so related to the lattice energy, okay, and Le Chatelier principle. Next come to the, okay, dipole moment, yes, dipole moment. After this, next bond parameters. Bond parameters. Last one from MOT and hydrogen bonding. Yes. So we can expect question from Poisson rule, ionic and covalent. Next hybridization. So VSEPR theory in that from geometry. Next lattice energy, dipole moment, bond parameters, bond length, bond angle, etc. And molecular orbital theory, the last small topic, hydrogen bonding. In that also sometimes we have a chance to accept the question. So these are the, okay, weightage topics from chemical bonding. Yes. Now we are going to enter into the chemical bonding. See. So chemical bonding. First, what is the definition of the chemical bonding? For example, we have here one molecule. That molecule contains constituents atoms like A, B, C. So what is the force present between them? They are together. So the electrostatic force of attraction which held the ABC atoms in a molecule, that force of attraction is called chemical bonding. So what are the theories they are explaining the chemical bonding? Chemical bonding first time explained by Poisson and Lewis approach. So this theory is called electrovalent theory. After this theory, okay, VBT, valence bond theory or orbital hybridization theory. This theory explained every molecule geometry. But if in that number of lone pairs, otherwise number of lone pairs present, the geometry is going to distorted. That one explained by valence shell electron pair repulsion theory. After learning these theories could not explain every molecule magnetic behavior and its correct bond order. That correct bond order, magnetic behavior explained by covalent molecules molecular orbital theory. So this theory is playing very crucial, essential role to explain the covalent compounds, their complete what valency electrons, complete geometry, and why the molecule going to distorted, what is the magnetic behavior and bond order. So all things these theories are explains. So now the first theory, what is the first theory? Coastal-Lewis theory. Coastal-Lewis, same type. Okay, they explained electrovalent theory. Yes. So this electrovalent theory specially explaining the valency electrons, because valence electrons are responsible to the bond formation. So this Coastal-Lewis approach given very fruitful result, explained the molecules, valence electrons and bond formation. First of all, we see types of chemical bond. What types of chemical bonds present in molecules and compounds? See, there are two types present. What is the first type? Primary bond. So first bond is called primary bond. What about second bond? Second bond is secondary bond. So how we can distinguish this primary and secondary bond? When the complete rearrangement of valency electrons, because valency electrons are responsible for bond formation. The participating the valency electrons which are completely rearranged, so that bond is called primary bond. Valency electrons, they are participated in the bond formation but no rearrangement. In the case of no rearrangement also bond is forming. Such bond is called secondary bond. So by this way we can distinguish primary and secondary bond. So by this way we don't know. So we know only covalent bond, ionic bond, but it is the main picture, the types of bond, primary bond, secondary bond. So that is depends on rearrangement of the electrons. So by this way rearrangement is very important for bond formation. There only we are dividing primary, secondary bond. Next, see the primary bond. What are the examples for primary bond? Primary bond examples are ionic bond, first one. So what is another name of the ionic bond? Electrovalent bond. Next, covalent bond. Covalent bond also called molecular bond. So last bond is metallic bond. So metallic elements, they contain bond. Such bond is called metallic bond. And secondary bonds, no electron rearrangement, even result is bond, that bond is secondary bond. Best example is hydrogen bond. So hydrogen bond is called weak electrostatic partial bond. Next, van der Waals bond, this also weak bond. Next, dipole bond. Yes, these are the examples for primary and secondary bonds. So after learning the primary and secondary bond examples, now the Eamcet question, what is electrovalence? So students here, they are very confused. We know the valency, we know the valence electrons. What is electrovalency? So electrovalency only present in ionic bond. So what is ionic bond? Ionic bond present only between the ions. What are ions? Charged particles are called ions. So charged particles, they have opposite charge, cation, anion. Between them, okay, electrostatic force of attraction is there. Okay, so that makes what bond. But here number of electrons transferred from one element to another element, then result is ionic bond. For example, see here NaCl, MgCl2, AlF3. Here sodium, okay, last one electron, that is transferred to the chlorine. Result is what? Ionic bond. Same way magnesium. Magnesium, how many electrons here lost? 2 electrons. So by lost 2 electrons, they are transferred to the chlorine. Result is ionic bond. Same way in the case of the aluminium trifluoride. Aluminium also here lost 3 electrons. So that every one electrons, okay, transferred by transferred to the towards the 1 fluorine. So 3 fluorines. Result is AlF3. In that ionic bond is present. So these 3 are examples for what ionic bond. So ionic bond, how many electrons lost, otherwise transferred? That number of electrons are called what? Electrovalence electrons. So such valency is called. Electrovalency. Now tell me, what is the electrovalency of the sodium? 1. Here no need to say the charge +1, -1. Only only here electrovalency means, so how many electrons what lost or gained to form the ionic bond. So here sodium electrovalency, how much? 1. Chlorine also 1. What about magnesium? 2. Chlorine 1 only. Aluminium 3. But fluorine 1. So it is called electrovalency. Now here compulsory required formation of the ionic bond, cations, anions. So first cation. What is the charge of the cation? Positive charge. Yes. So what are the favorable conditions? Formation of the cation, low ionization potential that favors to form cation. Next, low charge on cation, okay, that also favors to form the, okay, what? Ionic bond. Large atomic size also one aim to form the ionic bond. Inert gas configuration. So inert gas configuration contain ions. They are favored to form the ionic bond. So first, these are the essential things to form cation. So after cation required what for us? After cation required for what? Anion. So same way here anion also required. So now we see the examples for cation. Low ionization potential. Can we take the first group elements? Yes. First group elements, which one? Lithium, sodium, potassium, rubidium, cesium. So these are first group elements, alkali metals. In that, which one has the low ionization potential? Low ionization potential depends on what? Atomic size. So down the group, atomic size increases, then ionization potential decreases. So which one readily forms cation? Cesium. Cesium has low ionization potential, so it readily forms cation. Next, low charge on cation. Cations have the more than one charge. For example, we take sodium. Sodium charge is 1. Magnesium charge is what? 2. What is the aluminium? Aluminium charge is 3. Yes. So these 3 also cations. They have different charges. So which one has here low charge? Sodium has here low charge. So it readily forms cation. Large atomic size. Now we take example, potassium rubidium. So in potassium rubidium, which element has the large atomic size? Rubidium. So rubidium readily forms what? Cation. So cation formation, okay, favorable conditions these are. Next, inert gas configuration. So element which has the inert gas configuration. For example, we take here which one? Calcium. Okay, next we take zinc. Yes, both are here formed what? Cations. So calcium here +2. So what is the atomic number of Ca2 plus? 18 electrons. So 18 electrons is called inert gas electronic configuration. Now what about the Z2 plus? Zinc atomic number is 30. After losing 2 electrons, atomic number is 28. But it is not a inert gas configuration. So among this one readily forms cation. Why? Due to the inert gas configuration. Next, factors favorable for the formation of the anion. What is the charge of the anion? Negative. So small atomic size. So elements which have the small atomic size, they readily forms what? Anion. Readily forms the anion. As clear? Now can we see carbon? nitrogen, oxygen. So carbon, nitrogen, oxygen. In that, which element has here small atomic size? Oxygen. Carbon, nitrogen, oxygen. Oxygen. So here oxygen, due to the small size, readily forms what? Anion. Next come to the high EA and EN. What is EA? Electron affinity. What is EN? Electron negativity. Elements which have the high EA, electron affinity and electron negativity, they are ready to form. Otherwise they instantly forms anion. So for example, we take which one? As phosphorus, sulfur, chlorine. Yes, phosphorus, sulfur, chlorine. Phosphorus, sulfur, chlorine, all are what? These electronegative elements, because they are non-metals. So which non-metal readily forms here anion? Chlorine, because chlorine has electron affinity and electron negativity is high. So chlorine readily forms anion. Next, low charge on anion. So low charge on anion, nitrogen, oxygen, okay, fluorine. So what is the charge of the fluorine? 1, -1. What about oxygen? -2. What about nitrogen? -3. Yes, see. So low charge on anion. These three are anions. So which anion has here low charge? Fluoride. Yes, fluoride has here low charge. So it readily, all are forming anions, but readily forms fluoride because already formed. It readily forms ionic bond. So these are the conditions for favorable conditions for the formation of anion and cation. So after, okay, anion cation we completed, but in this lesson, okay, very important topic is hybridization. So 90%, 90 to 99% we have a chance to get the question from hybridization. Yes, fourth year is there, they explained okay, these compounds, but in that orbital hybridization theory is very important. So now we see the orbital hybridization. Before orbital hybridization, for what is the definition of hybridization? What is hybridization? Intermixing of two or more atomic orbitals. So intermixing of two or more atomic orbitals of same atom means here one atom's orbitals only participate in the bond, okay, hybridization. So that atom is called central atom, same atom with similar energy to form a new set of hybrid orbitals. So what about intermixing of two or more atomic orbitals to form new set of orbitals? They are called hybrid orbitals. Okay, they have same number and same shape compared with the atomic orbital. So this process is called hybridization. Hybridization. Okay, I hope you understand the definition of the hybridization. So now we see types of hybridization. So what are the types of hybridization present? See, first one, SP hybridization, SP2 hybridization, SP3 hybridization, SP3D hybridization, SP3D2 hybridization, SP3D3 hybridization. Yes, these are the types of hybridization according to our Eamcet syllabus. Now we see one by one. So what is the first hybridization? What is the name of this hybridization? SP hybridization. SP hybridization. See, how many orbitals participated in this hybridization? 2. They are S and P. So what is the shape of the S orbital? Spherical. What is the shape of the P orbital? Dumbbell. So SP, they are intermixed. They underwent hybridization and formed here what? Hybrid orbital. So how many hybrid orbitals they formed here? 2 hybrid orbitals. What are they? SP, SP. So SP, SP2 hybrid orbitals we got here. So what is the shape of the sp hybrid orbital? So sp hybrid orbital shape is linear shape. Linear shape. See here, large lobes only present. This figure indicating after hybridization. So before hybridization, atomic orbitals s and p. So after hybridization, these are called hybrid orbitals. So this is the sp hybrid orbital geometry. So what is the geometry? Linear. What about the bond angle? Bond angle is 180 degrees. 180 degrees. Next, which hybridization it is? SP2 hybridization. So SP2 hybridization, see here. So how many hybrid orbitals? So totally how many hybrid orbitals present here? 3 hybrid orbitals present, yes. So how many atomic orbitals? 1s, okay, 2 p orbitals, they intermixed. Result is what? 3 hybrid orbitals. 3 hybrid orbitals. Here example we got here. See the example. Carbon carbon double bond is there. Yes or no? So carbon carbon single bond. So hybridization is sp3. Carbon carbon double bond. What is the hybridization? Yes, carbon carbon double bond hybridization is sp2 hybridization. Yes. So hybridization is sp2. When sp2 hybridization is there, what is the geometry of the molecule? sp2 hybridization. What is the geometry of the molecule? Molecule is trigonal planar. So what about its bond angle? 120. Now here we discuss one Eamcet question. So what is the ratio of here hybrid orbital and pure orbital? What is the ratio of hybrid orbital, pure orbital? Now see the structure. How many carbons there? 2 carbons there. So I take here carbon. Carbon atomic number. So what is the carbon atomic number? 6. Now electronic configuration 1s2, 2s2, 2p2. Yes. This is the ground state electronic configuration. What about now excited state electronic configuration? 1s2, 2s1, 2px1, 2py1, 2pz1. So how many atomic orbitals they underwent hybridization here? Total 3 only. Because hybridization here sp2. Because hybridization here sp2. Now how many carbons present? 2 carbons. So each carbon hybridization is sp2. Total how many hybrid orbitals present here? Total how many hybrid orbitals? 6 hybrid orbitals. sp2 means 3, this carbon 3 and this carbon 3. Total 6 hybrid orbitals. Now how many anhybrid orbitals present? Now see, carbon we written here electronic configuration. So 2pz is what here? Pure orbital. Anhybrid orbital. So one carbon contain one, okay, anhybrid orbital, pure orbital 1. 2 carbons there. How many total? 2s. So now tell me this carbon hybrid orbitals how many? 3. So this carbon hybrid orbitals 3. So this carbon 2 hybrid orbitals, 1 hybrid orbital, okay, that is overlapping with second carbon's hybrid orbital. So result is sigma bond. So 3, 1 is less, remain how many? 2. 2 of the sp2 hybrid orbitals of this carbon overlapped with the 2 hydrogens. Okay, result is again sigma bond. So these hydrogens or hydrogen orbitals are hybrid orbitals or anhybrid orbitals? They are anhybrid orbitals. By this way, this carbons, okay, 2 anhybrid orbital with hydrogen. This carbon 2 anhybrid orbitals of the hydrogen. Total how many now? 4, yes. 4. So what about hybrid orbitals? 6. What about anhybrid orbitals here? Or pure orbitals? 6. What about ratio? Yes. This is the 1:1 ratio. What? Hybrid orbital and pure orbital. So by this way we can expect the question. So what is the ratio of the hybrid orbitals and pure orbitals? Here we have to see, yes, first hybridization. Okay, next. We see the next hybridization. So what is this hybridization? Yes, this is SP3 hybridization. So how many hybrid orbitals total? 4 hybrid orbitals present. So again, best example is carbon. See this structure here. What is the central atom? Carbon. Carbon has how many hybrid orbitals? 4. What are they? SP3 hybrid orbitals. These SP3 hybrid orbitals of the carbon, they overlapped with hydrogen's s orbital. Result is what now? Methane. Result is methane. By this way, methane's formation taken place. Okay, by this way, methane formation possible. Now, can we say how many hybrid orbitals, how many pure orbitals here? How many hybrid orbitals, how many pure orbitals here? So here, hybrid orbitals, here we know already 4. So how many here? Okay, unhybrid, otherwise pure orbitals, 4. So what about ratio here? 1:1 ratio, yes. Okay, clear? But according to chemical bond, here required what? Only geometry. And what about bond angle? So what is the bond angle in the case of the SP3 hybridized molecule geometry? 109 degrees 28 minutes. Yeah, it is the bond angle of the 109 degrees 28 minutes. Yes. So now one question here. Yes. So CH3 hybridization is CH4. Hybridization is SP3. Geometry is tetrahedral. Now what about the ammonia NH3? So ammonia hybridization also SP3. In the case of the ammonia, central atom is nitrogen. Its hybridization SP3. But what about its geometry? Okay, does it form tetrahedral? No. Its geometry is distorted due to the lone pair. So that is the difference between hybridization and valency shell electron pair repulsion theory. Later this theory, the geometry of the ammonia explained by valency shell electron pair repulsion theory. Yes, now come to the next hybridization. So SP, SP2, SP3. What about next one? SP3D. Yes. SP3D hybridization. Total how many hybrid orbitals present? 3, 1, 4, 5. So best example is which one? PCl5. What is the central atom in PCl5? Phosphorus. So phosphorus hybridization is SP3D. Why? Because we learn it starting only. So hybridization credit goes to the central atom only. Here central atom is phosphorus. So phosphorus has totally 1, 2, 3, 4, 5 hybrid orbitals. They are SP3D hybrid orbitals. Yes. So what is the geometry of PCl5? Trigonal bipyramidal. See here, how many goes there? 1. Trigonal. Yes. Trigonal bipyramidal. 1 chlorine is above the plane, 1 chlorine is below the plane. So what about the bond angle or not same? So here we have a chance to getting the 2 types of bond angle, 90 and 120. 90 and 120. Clear? So after SP3D, what about next one? SP3D2. So how many hybrid orbitals? 6 hybrid orbitals, yes. So best example is F6. Yes. Yes. Yes or no? Yes. Sulfur hexafluoride. A central atom is sulfur. What is the hybridization of the sulfur? SP3D2. SP3D2 hybridization. Yes. So, what is the name of the geometry? Octahedral. Geometry is octahedral. Now here bond angle only bond angle. So like previous we did not get the 2 types of the bond angle. Here bond angle 1 only, that is 90 degrees. 90 degrees. So what is the last hybridization? SP3D3. How many hybrid orbitals? 3, 3, 6, 7. So 7 hybrid orbitals present in IF7. Central atom is iodine. What about the geometry of the molecule? Okay, what is the geometry of the molecule? Pentagonal. Okay, like PCl, 5 trigones. Here how many gones there? 1, 2, 3, 4, 5. Pentagonal bipyramidal. One fluorine is above the plane, one fluorine is below the plane. The 5 are same plane. So result is, okay, result is pentagonal bipyramidal. Here we expect two types of the bond angle. One is 90, one more is what? 72. 72 degrees, yes. Yes, after learning successfully the hybridization, so now what is the task for the student in exam? To find out the hybridization, to find out the given central atom hybridization. So see, so if how we have small technique, so with the help of that technique we find out the hybridization of the molecule of the central atom. Now see here, if valency electrons of a covalent compound, because we are in chemical bonding, so we are learning only covalent compounds, those valency electrons 2, 2 as 8, so we can divide by 2. If 9 to 54, we can divide by 8. If greater than 54, we have to use 16 to divide. If we get the answer is 2, then confirm hybridization is SP. If we got the answer is 3, so confirm hybridization is SP2. If 4, so hybridization is SP3. If 5, hybridization is SP3D. If 6, hybridization is SP3D2. If 7, hybridization is SP3D3. Yes. So this small technique gives us information of the hybridization in covalent molecules. So see, download our app for great discounts on our courses. So here number of courses available in our institute. So courses and offerings there here, JEE, Eamcet, NEET. Okay, daily preparation, subject wise content is there. So next, see our parameters, free hand written notes available, free study materials, previous year questions, and weekend and every twice in week what free mock test also available in our Spark Academy. Now see the Spark store. So we say our institute is a Spark store. See, long term courses, crash courses, mock test for JEE Mains, NEET, Eamcet, IIT Foundation, everything available from our side. See, admissions open, classroom coaching also available and offline also available. See the short term coaching times, regular coaching, yes. So coming, the courses also available. Our two branches, one is Narayanguda and second one is Mehdipatnam. Now online coaching, so see, in online coaching our institute providing very best, see the online courses, NEET, JEE Mains, Eamcet also available, and use the coupons also there, you will get the discounts in that. Now daily on demand live sessions, how available, see here, some examples given, video classes, live classes, and common live sessions, and test details also there. Immediately you will get that test details. So how many students appeared, so what is the average your what time taken, what about your score, what about your grade, everything you will get the spontaneously. Now our methodology, see everywhere for every subject methodology is important. So our methodology topics given here, basic concepts. So basic concepts plays very important role. So shortcut methods, all model questions, exercise questions, Okay, weekend test, grand test, test analysis also available. Next, highly experienced faculty is there. Personalized coaching is there. Process oriented coaching is there. See, everything available. See, enroll your number. See the call 91333801 Yes. After we see some examples from this topic. Yes. So example number 1. See the example number 1 first. The S character in the hybrid orbital of the central atom present in a molecule having the shape of an octahedron is. So octahedron shape they are saying here. What is the shape here? Octahedral means octahedral. Octahedral means what is the hybridization here? Octahedral means SP3D2 hybridization. So here SP3D2 hybridization, because just now we learned it. So in SP3D2 hybridization, what about the S character? Now we have to see the S character here. What is the S character? Is it 25? No. Okay. Is it 75? Wrong. So option 1 is wrong. Option 2 also wrong. So what about, is it 40%? No. Because here how many hybrid orbitals there? Hybrid orbitals 3, 2, yes. How many? 6 there. So what is the S character here? S character here 16.66. So what is the correct option? Yes. So by this way, so percentage of S character also very important. So S character in the case of the SP hybridization 50-50. What about here? S percentage? Yes, clear. Has got it answer everyone. Yes. Now we go the next question. See the next question, hybridization of iodine in iodine heptafluoride molecule. So what about iodine hepta? Yes, 7. Yes. So how to find out its hybridization? Yes, how to find out its hybridization? What is the central atom here? Iodine. So what about iodine valency electrons? 7. What about every fluorine? Every fluorine 7. 7 into 7. So 7 plus 49 plus 7 56. Which number we have to take? Yes. Then what about the hybridization here? What about the hybridization? What is the hybridization? Yes. IF7 hybridization is SP3D3. So here by this way we will get the hybridization of the central molecule. Okay. So central molecule in the case of the IF7. So central molecule is I. So we got here by this technique hybridization. Now next question, say hybridization of iodine in iodine heptafluoride. Again same question. Yes. So don't confuse. So by this way also questions available. So what about here? Iodine hepta. Hepta, not hepta means what is the number? Yes. Here also hybridization is what? SP3D3 hybridization. Yes. Now next question. Yes. Now we have to find out hybridization of the some molecule ions also. See NO3 minus. So NO3 minus what is this? Nitrate anion. So what about here nitrogen valency electrons? Nitrogen valency electrons 5. What about oxygen valency electrons? 3 there. 3 into 6. So here minus means we have to add or remove. Add how many electrons? 1 because no number 1 only. Then what about here 5 plus 18 plus 1 19. 19 24. So 24 means which number we have to take now? 8. What about 8 3 is 24. So what is hybridization here? Yes, hybridization here SP2. Yes. Clear? Now next. Can we take the one more molecule now? Yes. Now we are taking which molecule? NH4 plus. So what about this ion name? Ammonium. Okay, ammonium cation. In ammonium cation, what is the central atom here? Nitrogen. So what is hybridization of nitrogen in NH4 plus? SP3D. No, we have technique. We have to use the technique. So nitrogen valency electrons, how many? 5. Yes. What about hydrogens? Every hydrogen valency electrons 114. So here plus 1 means minus 1. So what about here? Number we got here 8. 8 means we have to divide 2 4s are 8. So what is the answer? 4. 4 means hybridization. SP3 hybridization. Yes. So NH4 plus ammonium cation has SP3 hybridization. So what is the shape of the ammonium cation? Tetrahedral. Hybridization is SP3. Then it's a tetrahedral shape. Next. So what about hybridization of the I3 minus? I3 minus hybridization. I3 minus hybridization. Yes, we write here I3. Okay, I3 minus. So how many iode is there? 3 there, yes. Then 7 7 7. 7 3s are 21. Yes. Minus means plus 1. Total number 22. So which number we have to take now? Yes. Now 8 2s are. So what about answer here? Yes. May again. 2 3s are 6. So what is hybridization here? Total 5. SP3 D. Yes. So by this way we find out the hybridization of the central molecules and ions also, like ions, positive and negative ions also. Yes. Next, some questions for you. Okay, these are like a homework question. See, the first question: two atoms X and Y have 5 and 7 valence electrons. The formula of the compound formed by their combination is. So now see the options. So I repeat the question once again. Two atoms X and Y have 5 and 7 valence electrons. The formula of the compound formed by their combination is. So what is your answer now? What is your answer now? Yes. So can I give hint for you? Yes. Valence electrons responsible for bond formation. Yes, valence electrons. Now we started writing the compounds by crisscross method using valency electrons. So by this way you can use with the help of valence electrons valency and write down the valency of the X, Y. After you can employ the crisscross method, you will get the answer. Clear? So it is my hint. Next. Valence electrons responsible for the bond formation given by Cosell and Lewis. So some block elements, they are showing variable valency. So in periodic table, so which group, which block elements, they are showing variable valency? More than one there, but in that which block or which group elements they are showing variable valency? Find out. So I completed my hint here. Next question. During bond formation. So bond formation means two atoms, they are in motion. Yes or no? So what type of attraction takes place between two atoms? One atom nucleus to one more atom. One atom's nucleus to one more atom electrons. Second atom's nucleus to the first atom electrons. So by this way attraction is there, same time repulsion is there. So when they are coming to close, attraction takes place. So then what about they are in kinetic energy? So your question is, what about their potential energy? because you know according to chemistry and physics, so what about the kinetic energy and potential energy? So I give a hint, due to that you have a chance to get the answer. So here subscribe our channel, press bell notifications also, because from our side, okay, all facilities available, and same times, okay, we completed here chemical bonding. So once again we revise what are the important topics, subtopics from this chemical bonding. Okay, starting what I said, Poisson rule. What about next one? Next one is lattice energy and ionic covalent compounds. That it depends on Le-Chatelier principle regarding that. Next one, theories. In that important theory, VSEPR theory. Next theory is hybridization, orbital theory. Last one, molecular orbital theory. Apart, the remain are what? Bond parameters. Okay. Last, hydrogen bonding. So these are the main important subtopics from this, okay, topic. Thank you very much.